Kirchhoff's second law refers to a loop, not a circuit, but the law simply states that the sum of all electromotive forces is equal to the sum of all potential differences around any closed loop in a circuit. The sum of the EMFs is equal to the sum of the PDs for each loop. Charge could leave the cell, go through resistors A and B, and then return to the cell. This is one possible loop. Or the charge could leave the cell, go through resistors A and D, then return to the cell, and this is a different possible loop. Or the charge could leave the cell, go through resistors C and B, then return to the cell, which is another loop. Or lastly, it could leave the cell, go through resistors C and D, and return to the cell. So there are 4 possible loops. Now, circuit components are designed so the circuit reaches a steady state, which means that all charge carriers leaving the cell have the same energy, all charge carriers at a point between the parallel parts have the same energy, and all charge carriers returning to the cell have the same energy. This provides fixed potentials at certain points, and this provides fixed potential differences between these points. If the cell provides a potential of 6, then it will still be 6 over here. No matter which route the charge carrier takes, it will have a potential of 3 at the midpoint, and it will have a potential of 0 after passing through the last resistor, and 0 as it reaches the cell. Remember that a single charge carrier, which also carries energy, can only take one path, so we only need to consider one loop at a time for energy. This can look wrong if you think of this loop as being a series circuit, but it's not a series circuit, it's a series loop. So a series circuit, current is constant throughout. For a loop, current branches at junctions.